All right, so we're going to start off the chapter talking about the classification of matter. So matter is anything that takes up mass, or takes up space, and has mass. Now almost everything that you can think of is going to have some mass. So even if we think about a baggie full of air, that air still is going to have some mass. So nearly everything that you can think of is matter. About the only things that aren't matter are going to be emotions or feelings. So the chart that's on here shows that we have matter at the top, and we have pure substances and mixtures. So those are going to be the first two categories that we're going to look at. All right, so if we think about a pure substance has a fixed composition, which means it's the same all the time. It has the same ratio of elements or compounds or ingredients, but it's always the same every time. A mixture means that you're going to mix two or more things together, and there is no set ratio. So let's say you wanted to make a trail mix. You could have chocolate in that trail mix. You could have different kinds of nuts in the trail mix. You could have marshmallows. You could have chocolate. Whatever you wanted to have, you could put in there. And there is no set recipe for that. However, if you're going to make brownies, there is a set recipe for brownies. Otherwise, it doesn't turn out. And when we look at that matter chart, under pure substances, our choices were either an element or a compound. So if we think about an element is going to be anything that you can find on the periodic table. And they're always going to start with one capital letter, and if they have two letters, the second one is going to be lowercase. And a compound then is two or more elements that have undergone a chemical reaction. And they have to have a set ratio every time. So, for example, sugar is always C12H22O11 every time. It doesn't matter if it is best choice sugar or if it's crystal sugar. Sugar is the same every time. Water is H2O. So it has to have a definite ratio. So now we're going to go back over and look at our mixtures. And we said a mixture was mixed together, but they're not chemically combined. We can separate them by different methods. So, for example, you could run it through a filter, and you could separate out the solid from the liquid. Maybe you wanted to evaporate the water that happened to be in your mixture, and then that would leave behind the other materials. Another thing is we could use chromatography. If you had bigger particles in there, you could use some kind of a sieve to separate them, but you have to be able to separate them by physical means. We have two kinds of mixtures. We classify those as either homogeneous or heterogeneous. And if it's going to be homogeneous, that means it looks the same throughout. So we can't distinguish the different parts from each other. It just looks all the same. An example would be brass. Brass is a homogeneous mixture, and it has copper and zinc, but it's all mixed together and all looks the same. The second kind of mixture is a heterogeneous mixture. And this is one where you can see the individual pieces. So the example they have is I have copper metal mixed with water, and I can see the water and the copper separate. If you would think about like orange juice that has pulp in it, you could see the orange juice and then you can see the pulp. So you can see the different parts. Okay, so this is back at our chart. So we talked about matter being either pure substances or mixtures. And under pure substances, we talked about elements, which are on the periodic table, and then compounds. And we talked about heterogeneous and homogeneous. All right, so let's do some practice. So we have these four things and we want to try to classify them. So the first one's pasta and tomato sauce. Second one, aluminum foil. Third one is helium. And the fourth one's air. So take a little bit of time and see what you think about those. All right, so pasta and tomato sauce, I can see the pasta and the tomato sauce, and they're just mixed together. They aren't chemically combined, so it's just a mixture. Aluminum foil is just all aluminum, and so that's a pure substance. Helium, pure substance. And air would have different kinds of gases mixed together, as well as dust particles, and that would be a mixture. Okay, so here's another one. We want to classify these mixtures as homo or hetero, and you can pause the video if you'd like. So a hot fudge sundae, I could easily see the hot fudge and the ice cream and the nuts, so that would be heterogeneous. Shampoo all looks the same throughout, so it's homogeneous. Sugar water, if you have it all mixed in and it all dissolves, you can't distinguish the sugar from the water, so that would be homogeneous. And peach pie, I would have the crust, I would see the peaches, I could see some of the juice, so that would be heterogeneous. All right, so just to refresh our memory, an element is on the periodic table. It can't be converted into anything simpler, and it's made up of all of the same kind of atoms. A compound has two or more elements that have undergone a chemical reaction, and these always have the same whole number ratio, like H2O. So it has to be whole number. And then a mixture, remember, we just mix them together. It can have any composition. There isn't a set recipe for that. All right, so if we want to classify something, we can start with matter, and then we can ask ourselves, does it have a constant composition? Okay, if yes, then it has to be a pure substance. And the other question you can ask yourself is, can it be described with a formula? So if it has a set formula, then yes, it's going to be a pure substance. If not those two things, if it doesn't have a constant composition or you can't describe it with a formula, then it's going to be a mixture. And then under your mixture, you could further separate that into homogeneous if it looks all the same, or heterogeneous if it looks different. And then underneath pure substance, you can ask yourself, can it be described with a symbol, with a single symbol? If yes, then it's an element. If no, then it's a compound. And I would say even easier than thinking about that, look on the periodic table. If it's on the periodic table, it's an element. If it's not, then it's a compound. All right, so in this case, they give us some different elements like just hydrogen, neon, silver, or they give us some examples of compounds, H2O, and sodium chloride, which would be NaCl. And here they show us that exhaust, like would come out of your car, is a mixture of gases. We have water, we have some unburnt gasoline, we have some nitrogen oxides, and some carbon dioxide. So that would be an example of a mixture.